I'm going to kick this off the way I always do by finding my vertical asymptotes. That's the place where the graph cannot touch. So that's whatever makes the denominator equal 0, because you can't have 0 in the bottom of a fraction. If I can't solve this in my head, I do notice it's a difference of perfect squares. That's x squared minus 16. This is going to factor down into x and 4 and 4, and plus and minus. So the two VAs will be at x equals 4 and negative 4. You do need to have the x equals to get full credit. I'm going to go to x axis to where 4 is on the x axis and make one vertical line. And then I'll go to where x is negative 4 and make another vertical line. These are lines I cannot touch. For the horizontal asymptote, I'm going to look at these lead terms. That's 2x squared on top and x squared on the bottom. This will simplify down. The x squareds cancel each other out, leaving just a 2. So the behavior, the leveling off behavior, will be at y equals 2. On the y-axis, I'll go to where it's 2, and I'll put a line that crosses the y-axis at 2. So as I move out this way and this way, I'm going to level off at that graph. In the middle, I can cross this green line. For the x-intercept, I'm going to look to see what makes the numerator 0. So that's going to be what makes 2x squared minus 4x minus 6 equals 0. I'm going to factor this. I do notice I could do like a 2x and an x to try to get the 2x squared and multiply things out, and you can certainly do that. I will say though that all these numbers are even, so it's, I think, easier, in my opinion, if you divide everything by 2 off the bat to work with smaller numbers. And then we can just factor this x squared minus 2x minus 3. So these multiply to make x squared. 1 and 3 multiply to make 3. I need the inner and the outer to combine to make negative 2x. So this 3 should be negative and this 1 should be positive. If you factored it like this up here, you should still get x is negative 1 and x is positive 3 as your x-intercepts. So I'm going to have x equals negative 1 because that makes this equal 0, and x equals positive 3 makes that equal 0. These are dots on the x-axis. So x-intercept, go to where x is negative 1, put a dot. Go to where x is 3, put a dot. For the very last part, the y-intercept, I'm going to look at these last terms as if they were one single number. That is negative 6 over negative 16. That's a gross number. The negatives, though, cancel each other out. So this would, like, these would become positive, and then 6 over 16, I can reduce that down to 3 over 8. I don't really know what that is as a decimal, but I know that it's definitely more than 0. I know it's less than 1 because that denominator is bigger than that numerator. 8 won't go into 3 at all. So what I'm going to do is on the y-axis, just above 0 a little bit, I'm going to put my y-intercept. And now to draw the rest of the graph. So I've got 3 sections to deal with. I got a section over here, I got a section over here, I have a section over here. There'll be one curve for each section, and I have the most clues in the middle. So I've got to connect all 3 of these points, and I've got to also approach these vertical asymptotes. So there's kind of a natural curve to this thing, so I'm just going to follow that down like this, and follow this down over here like that. For this section, I do have some, like there's no dots, but that definitely means that as I level off, given the choice to either veer up or veer down, veering down is not really an option because there's nowhere here to cross the x-axis. So I will veer up. Not to mention the other kind of trick for this class, which is that across the vertical asymptote, the graph will be diagonal of each other. Left side, same idea. I have to level off at this asymptote. And as I approach the vertical asymptote, I either have to veer up or veer down. But veering down is not really an option because that would make me cross the x-axis and there's no dots to cross. So as I approach this vertical asymptote, I've got to go up like this. And that does, again, keep in line with the idea that in this particular class, for rational functions, the curves will always be diagonal over a vertical asymptote. So there you have it. You know, as long as you know where to look and you understand how to put it on the graph, whether it's a line or a point, this is very doable. So good luck.